I think I'll start off because I'm in an engineering college, so everything is about engineering. We all try to dream something. We also want to build something. I only realized that something today that I'm standing over here and talking started about 30 years back on the same GST road when I used to come. My dad grew up in Singapore Malkoval, which is just probably few minutes from here. So we used to drive down on a regular basis. அங்கே வந்து வரும்போது the standard factory is there. I'm not sure, many of you not would have seen it, but now it is called Shriram Properties over there, Gateway Property. So there used to be a big factory called Standard Factory. So I used to always tell my dad when I was about 12, 13 years that at one point of time I want to buy this Standard Factory and I want to build a car or a truck, what they were trying to build, because Standard 2000 was a very car that I actually liked and I wanted. So that's a small boy, just like many of you who are kids, like my son is 11 and they all think about small things. And I had this big dream and to be honest, everyone laughed at me. Everyone said he is just trying to say something so big that is not possible. It's only big industrialists could do it. And so happened, fast forward, I ended up taking a dealership in Mitsubishi earlier, and the owner of the same factory was also the owner of that dealership. And that was in 2008-9. And forward to 2019-20, I started something called, or rather worked with the founder on Ozone Motors. So I wanted to get into electric cars. So we had a racing team, we had a couple of dealerships, we had one of podium standing racing team, and designing of cars was done in one of our garages in Ambattur. When we looked at how to build cars, and that's where I learned that a lot can be done in terms of changing in terms of engineering. Okay, engineering is not the same as what you have to think 10, 20 years back. Probably 20 years back that was different because there only petrol and diesel was there. Fuel was just about 100 years old. So people started using petrol and diesel cars. So now coming to the sustainability part and looking at the environment, I think today engineering has to be different. And I put up some slides. So I will just try to use your people's help to go through the slides as well. And you can see in the slide is, this is the reason why we have to start looking at sustainability as a model in designing and engineering. Because understand, one of the most core important point of all these things across the world is engineering. Everything in the world is driven by engineers. Whereas we might not give a credit to all of them, but that is the most important part. Doctors and everyone is needed, but if engineering is not there, there's no infrastructure around. So, and one of the most important infrastructure is the mobility infrastructure. If you want to have your food, if you want to buy anything and everything has to be moved one way or the other. It comes in the train, it comes in a ship, it comes in a cargo vehicle, it comes in one way or the other. Even a bicycle has to be taken out. Even in the farms for plowing, you need machineries and equipments. So what happens is the CO2 emissions and sustainability and norms and all are there. But as a human being, if you walk on the road, not only in India, across the world, if you go to any of the beaches, you go to any of the rivers and ponds, you can see dirt everywhere. And this garbage is created by us. It is not by someone else. It is not by our ancestors. It's not by the future generation that is going to come. This is the current generation in the last 20 years have created that, and we are just increasing it. So now comes to the part is it cannot go on. We are increasing the population by about 2 crores every year, rather every other minute as well, we are increasing. So you have to, 2 billion is the increase of population of the world every, I think, 2 or 3 years. And I think we have to look at how sustainable way, how lean, how small, how compact we can start getting into manufacturing. And that is where engineering becomes one of the key part of it. And so 2050 is the goal many people have. 2030 is the other goal, that also 35 is the goal that the government has. So we have to reduce our CO2, sustainability, reusable, repack, and all that. And we can go. So this is where the future design thought process, according to me, has to come about. So It cannot be just one concept of taking and designing it. You have to have a data linked one. Data is very key. What we didn't have access several years ago, you younger people have access to a lot of data today. Inigor product pannanu or technology innovate pannana, you have Google and you have so many other researchers who will give you the entire data. Market data is available, tech data is available, your technology is there in computers that you can use to do a lot of analytics. Today, design has come down from 3 years, 4 years. It used to take to about 40 days, 50 days. You can design a product and get it out. And few are getting it within few days also. With 3D printing, literally you can create a product overnight if you want. So it's only the imagination and creativity. But this all can be done with a data-centric approach, because data is very key for you to use all these aspects. You have the other part is obviously design thinking. You have to have manufacturing, lean manufacturing. 3D printing is one of the concept of lean manufacturing, right? What was actually a product being made in the big machines, if you say vacuum cast machines or plastic mold machines, today are being made in a small printer that can be kept in your house, that can be used in your labs and other places. So I think that concept of manufacturing also has come to a lean manufacturing, where I can make a small concept today. Today you can make coffees and you can make a couple of other machineries in a small lathe house, which used to actually be made in big factories earlier. So this is a concept where you have to try to see how can I incorporate, because design has to become very important. Without any kind of a great design, thoughtful design that is unique as well as it's reusable and usability, the products, the materials that is used, the material science becomes very important of all these. So when you look at all these aspects, you have to make sure that all of them work together. And if I take smart manufacturing, again, you have cobots today making, you have robots, humanoids that are coming up, you have robo-dogs that are there, which can be used for many things. You have these small bots going around on 4 wheels. So these are also changing the way things are getting done. Today, most of your shipment that's coming from any of the e-com player, if you go to the warehouse, you won't see people, you will only see machines and bots doing all the work. And these are all small bots. These are not huge machineries. And that's where the entire dynamics of it changes. And the context of this is, I started thinking about this when I wanted to look at building our electric car. So we had come up with a small electric car. I'll show you that. But the thought process of design and engineering, what comes about, is very important. Next one, please. So for me, this one slide is very important. Obviously, we're coming from a Vedic culture of India. We have one of the most historical times, 5,000, 10,000, 20,000 years. Probably we have scriptures to say that we existed for so long. And if you see across Egypt, even if you take the Norwegian region, you take the European region, you take the Indian region, we always have these elements of sun and earth and moon and all. So they are called the Panchabhutam, or the 5 elements of life. So on these 5 elements of life is where I feel that we have to do engineering today, keeping this as a concept, where my engineering is not only about smart engineering, but also about value engineering, right? So how am I going to do something that saves planet Earth in terms of space? Can I make it in a smaller, compact way, the same thing? How clean can I be so that my air is really going to be clean? I can use clean energy or sources of energy that are not going to be from either fossil or anything that is going to create a lot more CO2 that is adding to the already CO2 available in the air. And then you have limitation of space is something we all say. I will say as limitation of usable space or livable space is where we have to see, because I can't keep making industries bigger everywhere. I can't have a 400-acre industry coming up across the cities, because we also are people, we need people to stay, so we need that kind of an industry. And the most important thing is pollution of the air. How I can save my water and air, because without these two, human beings cannot stay, and we would need this for our survival. So that is how I started designing and thinking of concepts of how we are going to do it. And next is what I will show you, what we have tried to achieve. So the data, again, saying that I follow this approach. I start with data. Data can give you a lot of different things to play around even before you start thinking about building a product. The data can give you the most important part when I build a product is not the product for the business, because end of the day, you have to make a revenue. And I think that is very important for you as young minds to think anything that you have to do has to be sellable, right? That's why you're building it. Either it gives you money or it gives you a reward, or some way or the other it is helping you. Or it is going to be helping in the sustainable aspect in a way where you are having someone CSR or someone who is ready to pay for that, to use that to save lives or save people or however they are going to use it. So that kind of importance comes about. So you have to have a design intelligence, you have the business intelligence, you have to have environmental intelligence, you have pretty much every intelligence part available. You have today AI, you have artificial intelligence, you have cognitive AI coming up. But the main important is intelligence is not only in one part of the data pass that people are talking about. AI just helps you to communicate and try to get a lot more information out of it. But these are basic principles that you have to follow, because intelligence is in the data and data can build you most of these answers by yourself, even before you take the next step on designing or developing a product. And I think this is a concept that has to be learnt about. Next, please. So I think this is something we have done in terms of sustainability. Our goal was, I wanted to build a lean factory. As I said, I saw this factory, which is I think about 100 acres or something else, 200 acres, which was my childhood dream. But when I came to the aspect of today, when I'm trying to design something, I said, boss, 2019-20, when we were looking at something, we said, boss, let us build a big factory. But when the product came out in 2021, we said, no, we cannot use a big factory. I think we have to rewind ourselves and look at it. So design the first lean factory, a micro factory, which will be a hub and spoke model, so that we can do it in a 40. Like this kind of an auditorium setup, I can actually build about 10 to 15,000 cars a year. And this is not something people have heard about. So when we looked at, so we got incubated by DICV, which is Daimler, and Daimler looked at it and said it's possible. And thankfully, 2024, people ask me this question whether you will be able to do it. Now, Elon Musk was the same person for us, where people used to say, well, he's building gigafactories, so what you're talking about lean and micro factories. And 2024, he's talking about micro factories, and then people calling and telling, Ajesh, I think you were thinking ahead of time, right? So that's how it is. It's not I'm thinking ahead of it. Even China is doing it also. So only thing is their usage or sales is so high that they cannot build small ones, but they have to build massive ones. But they are still lean manufacturing as well. So that is how we said we want to, the car has to save about few tons of CO2. So we said we will go for a pure electric car. We will try to reduce the size of the factory, as I said, the footprint by about 11x. That basically means I can do something what others are doing it probably in 100 acres. I can do it in an acre or less. And we will want to save about water. We save about 2 lakh liters of water just by getting into lean manufacturing. Cars, automotive, steel, and all these kind of many things that comes waste a lot of water. They go back to the Mother Earth, and also a lot of effluents. And I think that was the main reason I wanted to make sure we reuse or lesser amount of water that has to be discharged and more of recycled water. But again, for the painting and other things, we wanted to do a lot of other things. So that is where we come up, what all we wanted to do. We wanted to reduce our entire investment also. That was one of the key aspects where we started, because as I said, business intelligence, right? BI comes, finance is important. I have to make sure if I have to compete with the big guys, my outlay of cash has to be less, because I'm a startup. I cannot have the same thing of saying I'm going to invest 10,000 crores or 20,000 crores or 30,000 crores. It seems good, but I want to see how we can do it in a concept. So next one. So that's the one we went. So when we started, we thought of making car in a box. That was our dream, is my car should be able to fit in a box. I ship it to your house, and you should be able to put it up like a IKEA, just screw and bolt or a nut, and just do it up. But yeah, it is possible, but India is a little bit ahead for it. European market, they will still go ahead and do it. I lived in the US for 10 years, so I will say everyone has a small garage in the house. And they do a lot of things, but India, we still rely on our neighborhood mechanic to do all the things for us. So that's the concept we came up with, and this is how this is the third iteration. 2021, we showed the first model. 2021 to 22, we actually iterated it more. We worked with the users to understand what it is. So now I'll come from the engineering concept, how we started with. So we built an entire electric platform for this. And that is what this is based on. These are just specification sheets like every other car, just to show that we are as competitive as any other car. We are about 85% the size of a WagonR in terms of internal cabin size. It's a 3-meter quadricycle category. So I don't have to go to compete with a big car, and ARI can give me approval much faster. So also when you come up with products to be launched, you have to also see your certification patterns, your time to go to market, and how you're going to be able to do it faster. And for me, quadricycle is better because now I don't have to do 10 cars, give it for crash test and all that. So it helps me get to the market much faster. And, but we still use 4 airbags, whereas mandatory is only 2. Safety we kept as a priority. And the most important part of it, I should say, which is kind of not shown here, is if you see the seats, they are made of hemp. They are recycled. The plastic that you see inside is all about recycled plastic from about 12 kgs of PET bottles that is used. And then the entire body, we started looking at making of composite or either plastic composite or metal composite, which again can be recycled and reused. So most of the car actually can be broken down and recycled completely and then taken. So we also said we won't use virgin steel because that is very expensive. And also, you have today recycled steel that gives the same or better quality with a little bit of more alloys used in it. So I think you can see comfortably 4 people sit. I'm 5'11", and I can sit at the back seat with enough space. We can put suitcases and all that. People said, if it's small and compact, how will you do it? We also have a space in the front to keep something, just like most of the other electric vehicles. Here can we go? And it saves about 6.36 kilograms of CO2, and tons of CO2 in a year, in about 5 years' time. And it's only, the price is about 6 lakhs. So as I said, again, most important is intelligence. How can I sell in the market? How can I compete? So this will be about 6 to 6.5 lakhs. We also have a solar roof that we have put on top in case you wanted. You have swappable battery options in case you just want to take one of the swappable battery options in the weekend to start the car. And so these are concepts that you have to think about while engineering. How can I reduce the cost, but at least make sure that people don't have that anxiety when they have, in terms of range anxietiness. You can take a fixed battery of 150 or 240, but then you have swappable options that give you additional. If I want to go on the weekend somewhere, I want to go to Pondicherry just to have a weekend and come back, I can put 2 swappable batteries, go and come back and give back the batteries. And then I have a solar charge, so now I don't have to look for a shade to park. I can park it in the hot sun, and I'll still be able to get the same kind of, about 3,000 kilometers a year is what you get free of cost energy into your car. So this is where most important for most of you would be in terms of tech, as well as I think it's a medical college. I don't know how many people are from there, but we also built on an ambulance basis. So it will be a smart ambulance where you can have everything inside and be monitored. So you don't have to have a patient to put a lot of things. You have sensors and others you can monitor also if you want. That is something, a concept we have designed. But if you see on the left, that is the skateboard platform. It's a smart multi-modular skateboard platform. So, and if you see from 2019 to 2020, what all we have built. And so this is the primary vehicle that we have built, roll cage structure. That's the sturdiest. I come from a racing background, so we use a roll cage structure in the cars. So we put the same as the frame. So this reduces our manufacturing. If you see, most of the big manufacturers show you a big factory with a lot of things moved around. That's about, they're moving about close to 0.5 ton to 1 ton of vehicle around on either big lifts and other things. But in this, we are just making a roll cage. That means you can push the vehicle around and take it. So those are the concepts we have come. It's a smart car. Obviously, we are in mecca of technology. So we have to make it as smart as possible. So we have vision tech on the front, so and cameras around, so we can capture a lot of vision data. So we can pick up all the data around when it's going. You can pick up the potholes, and you can actually send the data to the car and ask it to be preventive and proactive actions can be taken. And lot many other things. I can keep going on because we are working and designing for future, say 2027, 28, 30. So we have to make sure that most of the engineering is based on what all we can add in the car in the future. Some technologies are great, but not cost effective today, but they will become cost effective tomorrow, but then I can't do re-engineering for my car. So keeping that in the thought, we also did the entire OS. So we are the first to build a vehicle OS in India as well. So we have our own vehicle OS that was built in-house, and that supports us in able to replace our batteries, replace most of the things that we want, or use multiple OEMs to play around with. And it can be done from either from a 4-seater, 2-seater, to a 8-seater buggy or a 20-seater. So, next. Next, please. So that's basically about the car. And I think, so we have also used the architecture to build the first commercial buggies in India. If you see, you have seen the golf carts, which are basically only last for about a year and a half because they are supposed to be used on the grass and not on the road. And also only 4 people are supposed to sit and 8 people, 10 people sit. So since we have already built a modular structure, we said, okay, let us sub-use it and try to see what else we can do. And this was the easiest because now I don't have to go to ARI, I don't need any approvals, I can start building and selling. So this is another division that our founder has taken, and then they are building this also and selling it to one of the players who are already selling buggies right now. So it's a fully connected car. So if you see, we are using CCS2, which is the latest technology as such. So the concept of showing this is basically showing that we are not using this was 2019 when we started the designing, in 1920. So we had thought about the technology even many are not using today. And these are in competition to most of the big companies which are using, including Mercedes-Benz and Kia, EV6 and others. We have started using, we put CCS2 at that time when people are coming today. Even Tata doesn't have CCS2 for a long time. So we try to design what we had to do in the future so that we are not redundant when you come there and we don't have to restart everything. And that again saves a lot of cost in terms of R&D and, or rather I would call lame R&D. You should have to have a very productive R&D to come up with future technologies and new things. We can move. So that's again the same. Next. So again, what did we do in the engineering is what is the result you see down, is what are the most important part of it, right? So we have, for the earth, we made sure we have a smaller footprint, we have a smaller manufacturing, lean manufacturing concept. Our factories will be about 11x to 20x smaller. Our entire infrastructure that is used about 20x smaller than a big player. And we have a hub and spoke model. That basically means I'm not using 200 acres or 100 acres of land in one area. I'm using about 1 acre in probably 8 areas. So even my transportation, logistics, everything is saved and I'm closer to customers. And this way, but my R&D is in a central hub where I make changes and my mother plant makes the changes in the technology which is readily available and adaptable everywhere. So this way I can go even global much faster than most of the others can. And this is a concept you have to start thinking whether everything and anything when I build as an engineer, can I use the design sense to do this? And we spent a lot of hours, and I should say credit to our team who have done all those hard work. So in terms of water, we about, as I said, we save about 2 lakh liters of water. We also made sure that the paints are actually cobalt, single harm technology is there, so we cobalt painted, so you don't have to dip paint them. And a lot of materials are reused. That means I don't have to go through my virgin steel to actually go through the entire process of manufacturing where water is used a lot. And again, effluents are not sent back to the earth. And we don't have to have a big reservoir or next to a water plant where we have to use, build a plant around. And also one of the biggest advantage of electric vehicle, apart from this itself, is being electric. You don't use a lot of oil change. நம்ம எல்லாரும் கார்ல பைக்ல எல்லாம் oil change பண்றோம். இந்த oil எங்க போகுது யாருக்கும் தெரியாது. And if you take your garage and he will take it and go outside and put it in the dump yard over there, or அவர் எங்கயாவது தண்ணியில தான் போடுவாரு. Unfortunately, that goes back to all the kuvam that you're looking at, and that's where the sludge happens. It goes down, and it creates a barrier and seal where you're actually killing the ecosystem, both the sea and the river ecosystem, or all the fishes and others. At the same time, water has to be drawn by earth to go down to cool itself, and we are actually stopping it from going back down. So as we need water to survive, earth also needs water to survive. If you know we have molten lava, we are saying if the molten lava is just like நீங்க வந்து கேஸ்ல டீ போட வைக்கிறோம், it's getting hot. At some point of time we have to turn it on. கொதிச்சிட்டே இருக்க முடியாது, ரைட்டா? அதேதான். So we don't put water back to the earth, at some point of time, the heat is going to actually affect us than anyone else. And for the fire, basically electric, solar roof, solar, we can charge with solar, we have swappable batteries. So we made sure that obviously we are not going to use any of the fossil fuels, which again gives CO2. One thing everyone asks, ellarum adhaan kepanga, is electric actually going to be CO2 friendly? Yes, it is going to be CO2 friendly. I'll tell you a few reasons. When you see petrol, you're only looking from the petrol station to what you're using in the car on the tailpipe, right? To make every liter of petrol from the crude oil, it takes a lot of energy. And that again, you burn a lot of energy as well. So if you see a lot of petroleum refineries, you will see there is a light that is there on top, which is a fire, which is basically actually there are gases that are being fired around, right? So when you take that, yes, we are mining, we are taking and using lithium. It is a process. It is an energy consuming process. But at the same time, once a lithium cell is coming, I can reuse the lithium at least multiple times. We don't know 5 times, 10 times, 20 times, but at least we can use 3, 4 times. So that basically means I can get back 95% to 98% of the cells, all the rare earth material, and actually build a new cell. And the cost of building a new cell is not much from this, right? So it's only from the ore to lithium is a very expensive proposition, not from lithium cells to lithium cells again.